Okay, so here to pick up after our break, we're the name of the slide here is challenges in implementing these approaches, and they talk about what we call the black box nature of deep learning, because deep learning models, right, being like deeper than machine learning models, and they have all those multiple layers that they go through. Most people will not really ever have the ability to go through and understand how those models are working. Somebody had to engineer them, obviously, and it probably took a lot of time to build the initial models, or even the libraries that we use in Python to do that work, to make it simple for us to do higher level work. And people don't want to really delve into that. They don't want to like get into the weeds, basically. So because, and this is true with software too, we don't care how the software works as long as it gives us what we're looking for, right? So what it does in the background, behind the scenes, it's kind of like you order a beautiful meal from a restaurant. You don't care what they had to do to make that delicious, but maybe if you watch them cook it, you wouldn't want to eat it. You know what I mean? And certainly you wouldn't be able to explain it to somebody. That's kind of the black box concept. And this is true with code in general, right? Because when we use libraries that are pre-built, somebody took a lot of time to write out the original code in Python to make those libraries work. Do you really want to know what they went through to think about it and solve those problems? Or are you just okay with the fact that it gives you the output you're looking for? Um, yeah, so really getting in there and understanding the fundamentals of how this stuff works underneath is a challenge, right? Um, and we are hitting upon this stuff pretty superficial, when you're in retrospectively. But you have to start somewhere, right? Um, the language models operate at different levels, and it says requiring the analysis of context incorporation. So, like, what context are you asking the question in? It does matter, right? Just like it matters in regular conversation with a human being. Um, okay, so one of the things that does hit the news once in a while is they talk about how large language models hallucinate or maybe come up with information that isn't quite right, right? Where does that come from? Well, from all the stuff us human beings who are flawed feed into it, right? So you can spread false information. You could have content that's inaccurate and hopefully not harmful, right? Um, yeah. So, and I think this is kind of interesting. I saw an article last week talking about the X platform, which used to be Twitter, right? And they still have this problem on this platform that most of the traffic and comments of people responding to tweets on that platform are bots, are just pieces of software doing the interaction. 70%. That's a problem, right? Because you think somebody is like, oh, that great idea. Thanks for sharing, that kind of thing. But no, that wasn't a person saying that. 70% of them are bogus. Weird. That's really weird to think. So it's a problem, right? Um, you also get unintended failures, right? So, and they're pointing their finger at the fusion models here. So, like, you might ask a diffusion model to build an image of, I don't know, President Trump in a bikini. I'm just throwing something crazy out there, and it might not give you the right thing. So, it might, show him in a one piece bathing suit instead of a bikini. I don't know, but that's a bad example. But you can have stuff that fails, right? It doesn't give you what you want. And a lot of it is in the prompt, but also a lot of it is in the information fed into the whole model. It also, unfortunately, can amplify biases, right, instead of reducing them. And I think this is a big concern for the future from an ethical perspective, for sure. Um, so, like, if there's bias in the training data, that's just going to amplify as you start to deploy models that generate real content. And it says perpetuates misconceptions and discriminations, which is horrible, right? We do not want that to happen. So those are some of the byproducts. All right, so we've looked at this data curation thing now, and thankfully, and we were just saying this, you can curate your own data. So you can generate your own raw data, clean it, transform it, organize it, structure it, put it into a database, whatever, and curate it yourself, right? That's a lot of work, right? As you learn. But there are out on the internet and in the wild, as we say, in the programming world, a ton of curated data sets that we can access. And there are platforms where you can access this stuff. And amazingly, most of these data sets are free. Some are not, right? And I'm going to say like probably like the ones like an insurance company uses might be, you know, probably a paid data set. All right, I'll have you conceptualize a concept here. All right, if there's a data set that's built upon Wikipedia data, and we're going to look at a couple right now in just a couple of minutes. Well, Wikipedia is a public website. I can go to it, and if I had the time, I could go through every entry, every page, every article, and make a database of the contents, right, in a structured format that works for me. And then I could publish it and share it with people. A lot of work, but it's doable, right? But it's a public data set. What happens if you go to like a social media website where you get a free account and they have access to all the stuff you post and all the stuff you like, and then your political leanings and who your friends are and where you like to shop and what you like to eat and what music you like and what you hate and what you commented positive on, what you commented negative about, who you unfriended because they were politically, you know, off the deep end on the other side of what you believe. You guys feel where I'm going with this? That data set that Facebook collects, this is the price of free, folks, is for sale. So what if you'd start doing posts like, hey, you know, pro something negative and pro, I don't know, suicide or killing or something. Think of a bad topic, right? And you go spouting on social media about this, and then Facebook takes and sells that data to your insurance company. Like, oh, I was out drinking with my friends. I can't believe I made it home alive. Now your car insurance company has access to that information. How do you feel about that? So there are those types of data sets too. So, and these are one of the reasons why you got to be careful what you share publicly. All right, let's take a look at some of these. Meta Text IO has a very big set of information. I think somewhere on one of my tabs in the background here, I had pulled up their website, right? And they have a curated database, and I just want to show you here some of the ones that they have, and these are some of the other ones that'll paint back here, like the wiki summary one. Notice this one's in Persian now. Okay, not useful to me, right? But if I was in Iran, that might be a killer data set. Right? And as you go through here, you'll notice that they have a bunch of curated data sets that you can just access, right? And they give you a link to it, and you can read about it. You can get the data set, download it. Some of them are huge, by the way. And I want you to notice like the size of some of these, right? And I don't know if this is, well, these are the instances, not the gigabytes. But some of these are really, really large data sets. So like if you're gonna like pull them down and process them and run them, you better have a really powerful computer, lots of storage, and a lot of horsepower that can run these things, right? But the data sets are out there. People have done the work and have shared them. So the Meta Text IO is one spot where you can find a bunch of the ones that we're actually looking at. There is this one here, that's the one that I just pointed out in Persian, right? So some guy named Farahani back in 2020 did a summarization data set extracted from Wikipedia and put it in Persian, and it's 56,363 entries in CSV formats. In other words, there's topics or questions, 56,000 of them with answers. And you can imagine, you know, there's a lot of really commonly asked questions in that data set. Right. There's also the other one that it was a little farther down, and I think this may have been updated recently, if I remember right. But this one was extracted in 2017, where somebody went into Wikipedia and did basically the same thing. They took the data set, and what was interesting about this one is it leaves the original text structure intact. So you get like the whole thing, right? You don't just get like a little snippet. And then there's other versions of it that are pre-processed and more summarized, right? And both of them are present. That one is out there, and I don't know if I opened that one in a tab. So okay, that one's not there, but I think we found it here somewhere. Yeah, I think this is the one they're referring to. And I'm just going to click into it just for a moment. There's a paper on it, and then you can actually pull the whole thing down and actually look at some of the contents. And I'll show you some example contents coming up here. I forget which link kind of takes us there. Here's kind of an interesting one, right? Because a lot of the stuff that, people like us who code, like we know how to code in a few different languages or whatever. Whenever, like, at least in, pre-generative AI, whenever we had coding questions, a real common website to go to is Stack Overflow. Have you guys ever gone there, try to figure out your coding problems? And that's good. I'm glad you do, right? Because that's what you should do. It's like, hey, how do I blank? Or what's wrong with my code, right? And then you get like all these people chiming in and giving their opinions and answers. And so out of that data set, some people have figured out, well, when you have this problem, this is the solution, right? And they made that into a data set. Fascinating that somebody went through that trouble, right, to pull that together. Here, let me see if I can get to this one. One of these I think was accessible. And this one looks like it's an HTML format, right? Okay, that's not very helpful. Yeah, and see, they will let you try it for free. Okay, so I'm just in a circle here. This is not the one where I thought came up with a kind of nice little on-screen example. So I'm just going to keep pressing forward until I get to that one. There's this one here that focuses on Wiki News articles, right? So if you guys remember, Wiki News is the website that was set up by, what was the guy's name? See if anybody remembers this one, who left the country because the U.S. government was pissed off that he stole all these government secrets and published them on this website, right? Because he felt like the world should know, right? And then he got in trouble for it, and he ran to England, and they protected him. Assange, Julian Assange. Thank you, sir. Oh, Snowden. Yeah, maybe. Yeah. Okay.
So, Edward Snowden.
Edwards. Yeah. Thank you.
I used to work as a contractor.
Yeah, precisely. And there's kind of like a fictionalized documentary movie about that. I don't know if you guys ever saw that. I forget what it's called. That was kind of cool. That showed how he had to like get the stuff on a flash drive and then had to sneak the flash drive out, and it was not an easy process. So kind of crazy that somebody would do that. This one, it's a whistleblowing website, and it covers many different languages, by the way, which I think is pretty interesting. It says here the Wikinews dataset consists of entity mentions linked to Wikidata extracted from Wikinews articles. So somebody combined those two data sets, 9 languages, 5 language families, 6 writing systems. And I think maybe this is the one that we can, okay, so it just takes you to the core. I'm gonna try doing a download on this. I'm just really curious to see how large it is. Well, here it is. It's coming up in GitHub. So this takes me to GitHub, where you can actually get to the raw data of it. And I'm trying to figure out, right, I really probably shouldn't spend the time now to try to figure it out. One of these data sets, I mean, is the raw data set. So I'm kind of, yeah, not it. Anyhow, let's not waste time kind of hunting for nothing here. Moving along, we also have this structured data set built upon that in English and Spanish. And I kind of get the impression maybe this was the one. Okay, that one. So if you do find broken links in these slides, I appreciate if you let me know. There's one. I can try to fix it. Here's one that does a data set that's curated about tweets. So this is kind of interesting. Somebody's like pulling information off of Twitter or X, whatever you call it now. And so, you know, that little scenario I was talking about where people analyze your social media thing is a real thing, folks, right? And people kind of do it. I mean, if this is a public data set, and it has stuff in there like emotion recognition, emoji prediction, irony detection, hate speech detection, offensive language identification, sentiment analysis, stance detection, and it's in English and it's in the text file format. So this is really kind of, I think, kind of scary that people are taking this public social media platform stuff and analyzing it in this way, right? Now, if this is a public data set, right, just be mindful of this. This is a public data set. Anybody can get to it, right? And just take the wherewithal and the motivation. What happens like when your government is doing the same thing? Oh, we want to figure out who's going to like blow something up. This person always talks about building bombs. This person always talks about how much you hate the government. You know, maybe that's a good candidate for a terrorist or something, right? So, you know, they do look at that stuff, and you betcha. I mean, it is really kind of crazy. Now, I don't know, like I'm trying to get to one of the data sets, and for whatever reason, it's really fighting me a lot. And I'm trying to see, I thought I had this up in one of my tabs here. And this is the one I think I'm kind of, here we go. This is the Wikipedia summary data set. And I think what happened is I got to the Hugging Face stuff, which is coming up. So I'm going to circle back here. Oh, wait, it's next. Okay, perfect. Here we finally get to Hugging Face. Now, Hugging Face, by the way, is kind of, you know, like Kaggle is to data scientists, right, for data sources. Hugging Face is the largest repository of NLP data sets for machine learning on the internet. They have a library that we can use within Python that leverages this. And this is one of the best go-to spots. So they have data sets for text classification, text generation, question answering, text retrieval, text classification, and so on. And though I think maybe it's the next slide. Okay, and this is the one that I have up on screen here. So when I hit that link on Hugging Face, and I think what happened, and I should probably, I think I did this, and I don't know if I landed directly there. I did not. So I had to go dig around a little bit, but I basically ended up on this page here. And this is the link I'm looking at right now in the chat. And you'll notice this allows you to actually look inside the data set. So you get like a little sneak peek. What does this Wikipedia summary data set look like? What are, you know, it's a text file basically, right? What is that information? So you can see they basically have the title, the description, a summary, and then the full text of the Wikipedia entry. And so, for example, agricultural science, you know, a brief description, a summary, which might be a little bit longer, and then the whole Wikipedia article. So they're like associated, right? And it's in a data set that's for the taking. So I don't have to go to Wikipedia, write a Python code to scrape the website and extract the information I want. It's here. Fascinating. And the dataset viewer is showing only the first 5 gigabytes of information. I think that's pretty fascinating. This, I think, is a pretty huge. So the number of rows in the first 5 gigabytes is 430,000 entries, right? I just want you to think about how big that is. So the sample size has got 430,000 lines in like an Excel spreadsheet, if you will. Now, have you guys ever loaded a data set for this class or another class that might have like 1,000 lines, and how long it takes to load that up even on a fast modern computer? Can you imagine how long that would take? And then can you imagine how long it would take to run a machine learning algorithm over it? Or imagine how long it would take to put this together. Yeah, this is what we're talking about here in terms of the weight and complexity of these curated data sets. They're humongous, absolutely humongous. This is really kind of a really cool website, though, the whole Hugging Face thing, right? And I think they have a link here where you can go to kind of like the core data sets and look at all the different ones that they have. This is a website where you can set up an account if you wish. Notice that they have tutorials, how-to guides, and all that kind of stuff. If you want to try to find a data set, you can go in here and they give you examples for how to write the code in Python to go right to their repository or whatever and pull the information. I mean, this is really a cool website, folks, right? You can imagine that all these public-facing AI models are leveraging this stuff. And I think this is really cool. Basically, that you can look at it. I mean, that's the thing that kind of blows my mind about it, and that it's out there and it's basically free. We were kind of looking at this other data set. This is one of those that I tried linking to, and let me try this again. But I was getting this, and then I try to look it up, the big bad data set. I've never been on this site before, but right now this is a hosting error. This means like the website that they're putting it on, somebody forgot to pay the bill, or it got moved, or the web address changed. I did a straight up Google search on it, and it still brought me back here. So something's going on with it. So I wonder if somebody's got a mirror of it saved somewhere, hopefully. But this was one of those big data sets that a lot of people would use. I think a lot of this stuff too is also found on Hugging Face, so just be mindful of that. Right, now we're going to switch our discussion over to talking about some tools here. So now we know where to find some of these, right? And now let's look at some of the stuff that we can do to kind of leverage these data sets, because they are huge. All right, so we are going to look at a collection of different approaches for figuring out some of this natural language stuff and some of the tools that basically process the natural language. And then we will be able to do things like sentiment analysis, topic classification, and other tasks. All right, so NLP tools, and you're going to see here on the screen, right? And this is, mind you, a combination of like software packages, like you guys know the Jupyter Notebook, right? Or if you're using Visual Studio Code. And there's other, and many of these, real frankly, are online cloud-based tools that you can use that are built to handle some of these types of tasks. And real frankly, if you're going to do like these big heavy tasks, usually you're going to do the computational part of it out in the cloud on a server somewhere, unless you happen to have like a ton of machines with a lot of horsepower and you're doing it locally. There are natural language processing tools that are written in platforms other than Python, but you can see that the focus here is Python, and most of the work tends to either be available for Python or is predominantly Python anyhow, right? So some are libraries, some are tools, and a lot of it is Python related, right, as we've come to see. They're throwing a scenario at us to make us understand why we might need these tools. So it says you're part of a big organization, a new ticket arrives. First, it needs to be processed and assign a tag or category so it's routed to the correct team member. So think of like a support ticket for IT as a good example, right? It says manual classification systems are often complicated and take a long time. And strangely, I have that exact complaint about our IT ticketing system here at Gateway, because like I'll have a problem with a certain thing, and I'm like navigating like 5 menus trying to figure out like what category is this? Is this network or technology or classroom or bright space or what is it? Right. And that's one of my complaints. And then sometimes I just choose other and then let them figure it out. So this is of kind of what I'm talking about. So it's like I'm spending 5 minutes trying to figure out what category this fits into. I'm just going to choose other and let them sort it out, right? They will know exactly what category you throw it into. What it does indicate though is that their structure maybe isn't quite so clear, right? So how can these tools help? All right. They basically can give you a way to classify support tickets by topic to speed up the processes, right? So if I have people that are having problem, let's say logging into Brightspace, and it's categorized under Brightspace, I can just look at Brightspace problems, right? So it helps me focus down. So processing tickets becomes easy, right? If you're using natural language processing tools. And so let's look at some of those. And I'm thinking of an example here because recently we had an internet outage here, and I went to the Spectrum website, and then I think their bot said something, please explain the nature of your problem so I can direct you to the right answer, that kind of thing. What is it doing? Exactly what we're talking about, right? Focusing us down topic-wise. Okay, some of the real popular NLP tools are the NLTK, the Natural Language Toolkit, a tool called Text Blob, another one called Spacey or Spacey, maybe is how they say it. And then there's GenSim. So we're going to start looking at each one of these and break it down. All right, so the Natural Language Toolkit is one of the more popular model building tools for natural language processing. A lot of people use it. They have a bunch of tutorials that guide you. They have sample data sets. And you can learn more about it by clicking on that link, and I'll let you do that on your own rather than waste your time here exploring it. But I would encourage you to do that if you're really interested in it. It is basically a toolkit that allows us to do things like tokenization, tagging, stemming, parsing, classification, etc. Very common tasks. When we get into classification, right, like to put things in the right categories, basically, you give an example, deciding whether an email is spam or not, and deciding what topic of a news article is from a fixed list of topic areas. Is this sports or technology, or is it politics, or is it weather? What is this, right? That's kind of the point. So how does it basically work? It says basically during training, they have what they call a feature extractor that takes the input and then figures out what its features are and then puts it into a machine learning algorithm. Then that machine learning algorithm does all the classification processes, and then based upon fresh inputs, we can make better predictions. So there's the training and the prediction part. So this is still related to machine learning, right? So the machine learning does the processing, but we're using a different type of tool to process. So we have to extract the features of the language, and then the model does the rest, basically. There is this aspect of this NLTK that's just called the tokenizer. And we will, for example, have to import these libraries and then pull in very specific tools. And for example, one thing that you can do is you can take a plain English sentence, throw it in a variable, and then tokenize it, which would basically break the concepts of the sentence or the whole string of text into pieces. So tokenizing a block of text. So for example, if I type a paragraph with 20 sentences in it, it's going to break it down into 20 sentences. And what did it do? It took one string of text and turned it into a Python list with 2 sentences. Basically saying, oh, you got 2 sentences here, right? So that's a tool that's built into the tokenizer. Then there's a stemming algorithm, right? It takes the words and boils them down to their root, right? So it's like if I say chocolates, chocolatey, cocoa, all of those really kind of point to the root word chocolate, right? Yes. And maybe I could throw cocoa in there as well, and maybe not, right? Then we have the word retrieval, retrieved, or retrieves, all boil down to the stem word of retrieve. They're all variants of that word. Past tense, future tense, plural, whatever. So that process, getting to the root word, the root meaning, is called stemming, and NLTK has that. It also has information extraction. So it says one important form is structured data, where the regular and predictable organization of entities and relationships are put together. So really what this is getting meaning from the text. Ice cream, good. Steak, good. Because it says, I like ice cream and I like steak, right? It didn't say I hate them, right? So we're trying to get the root meaning from it. So information extraction, it says here, given a document that indicates the company Georgia Pacific is located in Atlanta, it might generate this, org Georgia Pacific, location Atlanta, right? So that's from the plain text, right? So Georgia Pacific is located in Atlanta. So what are the key pieces of information? Georgia Pacific is a company, an organization, an enterprise, right? Its location is Atlanta. So what's the key information in that phrase? Well, I'm dealing with Georgia Pacific and they're in Atlanta. And ironically, my wife's dad worked for them for most of his career, including in Atlanta and all over the country. Weird, right? Weird example. Look at the thing before, or down below, excuse me, where it says, if you read the words along the bottom, the little yellow dog barked at the cat, right? So what's this doing? It's taking the whole sentence, it's breaking it down, and there's all these little acronyms and whatever, and really it's extracting the information by breaking everything apart, right? So once again, tokenizing things really, and then breaking the words down, and then being able to identify their roots. So the raw text comes in, right? Sentences segmented, so sentences are separated. That's the tokenization process. Then we have a list of lists of strings, right? And then part of speech tagging, where we basically break down the words, like is it a noun? Is it a verb? Is it a pronoun? Is it a adjective? That kind of thing. Then we have what they call entity detection from the chunked sentences, and then we can start to relate those words to concepts, and the relations notice form a list of tuples. Remember, tuples are like lists, but they're immutable. We can't change them, right? So once they're broken down into the raw relationships, this means that, you can't change that information. So that's part of how it does information extraction from a high level. Another tool is text block. And you can consider this, as it says here, basically an extension of NLTK, and you can use some of NLTK's functions through text blob. So text blob becomes basically an interface for a simplified transaction with NLTK, right? Kind of like remote controlling something, in a simpler fashion than manually doing it. They say it's great for small projects, right? And you can read more about it there, so please do. What it offers, sentiment analyzers, for example, natural language processing technique, which figures out, are you in favor of this, against this, or neutral? Or, Republican, Democrat, independent, or whatever, right? So that's a big usage of this tool. Another tool is this Spacey tool. I think that's how you say it. Once again, an open source Python library. It supports deep learning, and it works with other machine learning libraries like TensorFlow, PyTorch, and some of the other ones that we've been playing with. So and you notice this a lot, that you'll get one library or tool in Python that instead of starting from scratch, uses a tool that already exists and adds features to it or makes it easier to use. Right. So this is really kind of an interesting idea programmatically, right? What it does really well is tokenization, and it does it in, it says over 65 languages. So that's a lot of languages. And that's a pretty impressive feat. So notice a little graphic there: dependency parsing, word vectors, language models, and entity detection. And you can go to their website and check it out. It has improved language data with support for a bunch of different languages, including most of the common Western languages. They have a little thing here that we can check out here really quickly. It says go to the website. If you go down the page, you find this prompt, and let's see if this is still valid. All right, there it is. All right, and it says change the language to English, and then explain the block of code. So English. I think I'm just looking at the settings here. I think I have them set correctly, right? And I want you to notice all the different languages it's supported. Hey, ancient Greek, who would have thought it, right? Just in case you need that. But oh my God, that's a very impressive list of languages they have here. And it shows you, and isn't this cool? It shows you the pip command to install it. It shows you the syntax for including it. And if you want to try some of this stuff out, you can actually copy this code and try to run it, which I think is really helpful. So the point of this slide is the different tools have different features and capabilities, and depending on what you're trying to accomplish, you can use different libraries. Now, this is really fascinating, I think, because as we've seen in recent years with the explosion of these Gen AI models, we are in this era, folks, where all the big AI models are leveraging a lot of these free tools as their starting point. And then some of the newer models or evolved models are just combining these different tools in different ways. We're developing new tools in order to feed them. And this is how we're getting this evolution. All right, here's a handy little chart that shows some of the popular tools and what you can use them for. And you'll notice that some of them are good at some of the same things, and then some of them just don't do certain things, right? So for example, none of these have a spell checker, for example. That's like a different algorithm or tool. So looking at what you might use it for, what you might want to, how you might want to apply this. They focused on libraries here once again that are Python focused, because that's what we have been doing. And then they have a little pro and con table, which I think is very helpful. For example, they look at NLTK and the first comment on it for cons is it's slow. Okay, well, it's slow. What are you going to do, right? Run it on a big, powerful computer to speed it up, hopefully. All right, let's move forward here. All right, so now it says we're going to compare some of the tools in detail. So a lot of like comparison stuff here, like why we might want to use stuff. Like for example, if you look at the little chart there, if you're a beginner and just getting started, it looks like Spacey and NLTK are both good tools. If you want to build a production application, you're probably not going to do it with NLTK. You want to try neural network architecture, the latest model, state-of-the-art accuracy, not these tools, right? These are public free tools that those good features you got to pay for, or you got to wait a while till they release them. If you want to train your models from your own data, or you want it to be efficient on your CPU, they're both okay, right? So Spacey supports word vectors, and NLTK does not. Spacey uses the latest algorithms. Its performance is usually good compared to NLTK, but for advanced NLP, you will prefer spacey instead of NLTK. That's kind of the summary of it. They start to do comparisons like how fast it is at certain tasks. So, which performance is good. And these are little bar charts that show how long it takes to process something. And you'll see that analyzing parts of speech, NLTK takes a long time, right? Where spacey is pretty quick. If you're looking at sentence tokenization, well, NLTK is a lot faster than spacey. So maybe you use NLTK for the tokenization, and then you use space to do word tokenization and parts of speech. I think that's a pretty interesting little comparison. And they have also this little Google Cloud thing, and I'm hoping this one works too, right? And it says where you can try the little API. So they have this like block of text in here, and they want to analyze. And of course, you have to prove we're not a robot. And then it takes it down and it breaks it into pieces of tokens, basically. And I don't know if you guys remember, we played with this tool briefly in the very first class, where it took that block of text and then kind of gave us like this, these are the entities, meaning the stuff within the text. Then we can do an analysis of the sentiment, right? And notice they have a scoring range on it. The moderation, including the confidence levels of the information, and then the categorization of the content. Sorry about that. With the confidence level to match, right? So some of that matches statistics and whatnot. So that's out there. And I think it's kind of interesting because I don't know if you can put your own text in there or not, but if my memory serves me right, I think you can. I notice that they call this an API. Now, the word API is a very important word in programming, which stands for Application Programming Interface, meaning you don't have to write the code. It's kind of like a Python library. You just need to know the right words and syntax to use to make it operate and do the thing you're asking it to do, right? So that's the concept of an API. All right, there's also this tool called Genism, and it's, once again, a Python library, and it's really good at the following things: similar text, indexing texts, and navigating different documents. So you can see why this might be kind of a good one to use. A really fast library on the training end. It can run on Linux, Windows, or a Mac. It supports Python and NumPy, and it can process arbitrarily large amounts of data using specialized algorithms, right? Whatever that means. All right. Versus other libraries, it's mostly designed for unsupervised text modeling. So you just give a text and don't structure it, and it will, classify it and break it down. It says it does not have enough tools to make it an entire NLP pipeline. So it's better to use it alongside the other two that we already talked about. And we kind of already alluded to that. That's part of the process. All right, so here's kind of the definition of API. So, and they give you a little example. Every time you use Facebook messaging or check the weather on your phone, you're using an API. So in other words, you're not necessarily writing the program, you're just triggering aspects of programming code specific to what your needs are, right? All you need to know is to either have the right tool on a high level, like pressing a button, or writing the right code to trigger it to happen. You don't have to engineer the code underneath. And a lot of programming is kind of done in this scenario. So they're giving us a scenario here. Consider yourself at a restaurant table with a menu of options to choose from. Your order will be prepared in the kitchen, which is part of the system. What's missing is a crucial link that allows you to communicate your order to the kitchen and have it delivered to your table. So this is the server. So this is when the server or API enters the picture. The server is a messenger or API that takes your request or what you want, relays it to the kitchen or the system, and then the server sends you a response, which, for example, is the food arriving and hopefully correctly, right? So you say, yes, I want a cheeseburger and fries with ketchup and mustard. They deliver it to the kitchen. You don't care how it happens, but it comes back and you have burger and fries with ketchup and mustard, and hopefully not fried onions because you didn't order those, right? And it's all kind of in that black box, as we like to say. So an API really kind of exemplifies the black box concept, right? Because we don't need to know how the library works. We just need to make it work for us, right? We didn't engineer it, somebody else did, and that's okay. All right, folks, that concludes the lecture here. Here's a reflection, some questions if you wish to ask yourself. Right, and I think those relate a little bit to the extra homework assignment, I think. The bibliography, first bibliography, and second bibliography. All right, and folks, that will conclude this recording, and this video ends here.